This question has a check on all concepts of magnetic fields. See, the curved portion is a semicircle, means it's half a circle connected to a long straight wires, and that means these are infinitely long wires. These are infinitely long wires. Now, for a full circle, current passing through this as I, then magnetic field, the crossed magnetic field, in fact let's take the current in the way it is required in the question. Then if the current goes like this, magnetic field comes out, and that means there is a dotted field, let's say B1, and this B1 is equal to mu naught I by 2 times, say for example if this is the radius, then mu naught I by 2r is the magnetic field at the center due to the entire circular loop. I require half the loop. Let's say we do not take this part of the loop. Let's say we consider only this much portion. That is from diametric endpoint till diametric endpoint, and then my calculation would still remain same with multiplication of a half. That means this will be mu naught I by 4r. Now next part is about the infinitely long wire that is proceeding in the downwards direction. Now see, this particular long wire carrying the current I is having this particular point of observation P in its path. So the magnetic field due to this part would be absolutely zero. Basically it should be mu naught I by 4 pi d, mu naught I by 2 pi d into half. So that d value being 0, the b value is 0. The perpendicular distance is 0. Whereas if you consider this wire, which is again an infinitely long wire, it has got a d value, and that d is equal to the radius. And therefore, due to this particular wire, the b value would be, let's say b2 is equal to mu naught I by 2 pi d. If it would have been infinitely extendable on both sides, if it would be infinitely extendable on both sides. But since it is not present on this side, this will be multiplied by a half. And therefore, the magnetic field due to the infinitely long wire starting at this point, it would be equal to mu naught I by 4 pi into d, and d is equal to r, and therefore this b2 value is equal to mu naught I by 4 pi r. This is because of this infinitely long wire starting from this point. 50% of the value if it would have been extending on both sides. Now, what about the direction of the B2? Now see the B2. The current I is coming in this direction. That means if I take the thumb in the direction of the current, the B field would come out. This would be a dot field. That means here at this point I have a dotted B2 field as well. That means this is a dotted field at P, and this is a dotted field at P, and therefore net field at P, net field, magnetic field at point P, the magnetic field at point P is an addition of B1 and B2. They are in the same direction, and therefore B is equal to mu naught into I by 4, or let's say 2R as taken common in the solutions. Mu naught I by 2R provides a half, plus mu naught I by 2R into a half. Mu naught I by 2R provides a 2 pi. Mu naught I by 2R provides a 2 pi, and therefore this becomes your answer, and this is the net magnetic field, which is same as this, and therefore this is the right answer to this question. And see, this involves the ideas about a curved path, a straight path but finishing here an infinitely long wire but in the line of the observation point. You need to be cautious about the ideas of application. Only the basic formulae or the results of the theoretical discussions will not be alone helpful. You need to apply them in the right geometrical setup. Only then you can make a question right in the smallest amount of time. Stay subscribed for more ideas.